Hello, I'm Richard Warburton, and welcome to this video on how to clean data in Excel with Python. In our previous tutorials, we've explored what clean data is and introduced the tidy data principles as a way to define what clean data looks like in Excel. We've also argued and demonstrated how using Excel in conjunction with Python not only opens up a lot of very useful tools for use in cleaning data in Excel, but also future-proofs your career by introducing you to Python and building the skills that are essential for data science and machine learning jobs. In this video, we're going to continue looking at how to clean data in Excel with Python. And specifically, we're going to look at some very common functions that would be carried out in Excel and demonstrate how they could be completed in Python. For example, we're going to look at splitting columns into multiple columns based on a delimiter, so the text to column function. We're going to be applying formulas to tables of data. We're going to be looking at lookups similar to the way you'd use a VLOOKUP in Excel. We're going to be looking at how to remove duplicates from data, and we're going to be correcting capitalization issues as well. Now, to do this, we're going to build on the example that we'd previously considered. So let's expand on the example from the previous article. The orders database contains more information than previously analysed. The database also contains the names of the client contact placing the order and the address of the client. In a separate company's details table, we also have the customer names and the sales representative for each customer. The increased availability of data means that we can produce much more useful analytics for the business, and they have expanded their ask as a result. We've been asked to provide a breakdown of total order numbers by customer name, sales representative and country. We've also been asked to isolate the individual name and address elements so that shipping labels can be printed. It's a perfect opportunity to look at how these functions can be implemented in Python based on data we're given in Excel. Let's inspect this data and understand why we should consider it a messy data set. If you recall from the last tutorial, we introduced the tidy data principles to explain why data wasn't suitable for analysis and give us 3 good principles to define what good quality data should look like for analysis. Let's walk through this data set through the lens of those principles and understand why it isn't a tidy data set and therefore is a messy data set. So the first principle is that every value is a cell. Now, if you think back to the previous tutorial, we carried out a lot of cleansing activity on the price per unit column. And we've got to carry out the same activity here. We can see that the values within these cells are not nice numeric values that prevents us from carrying out the analysis that's requested. So these values, while they are in a cell, are not in the format within the cell that we need to complete the analysis. The second area where we can see that values aren't necessarily cells is in the client address. We can actually see here we've got a long string of differing data points within a single cell. So there are multiple values within a cell here. Now actually, if we click on this and hit enter, we can see that there's 5 data points. Excel has jumped this onto individual lines now. And we know we're going to need to isolate each of these individual points for the analysis, particularly the country, because we've been asked to pivot data by that point. So we're going to have to isolate each of these individual values in their own cell to complete the analysis. It's worth noting at this point that Excel is hiding a character in this text string, and we'll see this later in Python. But it is a character that tells Excel where a line break needs to be when it's presenting on the screen. The second tidy data is that variables are columns. And actually, the example we've just looked at for the client address leads quite nicely into this, because each of these individual points could be considered a variable. And we're going to need to isolate that within its own column to be able to complete the analysis that's been requested. We can also see this in the order email. Now, the order email is a legitimate variable in its own right, but we have been asked to analyze the data by individual names. Now, we've got the individual name within the email here, but we're going to have to pull that into its own individual column for analysis. So the variable of an individual's name is something we're going to have to isolate from the email, and we're going to have to create a new variable to contain that data. The third principle is that rows are observations. Now, the observed unit here is an order by customer. So in one respect, we do have some information that gives us details about the orders by customers. But in terms of presenting interpretable analysis, it falls a little bit short. And the reason for that is that as humans, we don't necessarily know who customer 1 is. We don't know who customer 2 is. And we actually have that data stored in a separate table within the database. Now, there's nothing wrong with storing this data in a separate table. In fact, if you are familiar with normal forms of databases, it is actively encouraged. It reduces storage space. But from a data analysis perspective, if we want to pivot analysis by the actual name of the customer, we are going to have to look up this data into this data set to be able to pivot the analysis by it. So we're going to have to create a variable for customer name within this data set, and then add all the individual values and look up all of the individual values based on a mapping from the customer column here. So this data is messy. Before we can complete the requested analysis, we're going to have to carry out a number of cleansing tasks. Let's have a look at those in Python. Having inspected the data and having identified the issues to resolve, we can now devise a plan for cleaning it. This is as follows. First of all, we need to implement the cleaning from the last video to ensure that the price per unit is a numeric value. We need to apply a formula to calculate the total order value per order. We need to isolate the individual elements of the address and store them as separate variables. We need to extract the name of the ordering individual from the order email and copy it to a new variable. We will then need to correct the capitalization of the text values extracted. And finally, we'll need to check for duplicates in any of the tables before moving on to look up the values of the company name and sales representative from the company details table. Let's start stepping through the tasks we need to complete to cleanse this data. On the screen, I've got open the Jupyter notebook that is available to you in the lesson materials. And I've also got this in the same folder as the notebook. I've also got the messy order data and the company detail Excel files. The process we're going to follow is the same process that we outlined very early on in the series of tutorials, whereby we're going to import the data into Python. We're going to carry out the necessary cleansing activities, and we're then going to export the data back to Excel. So the first thing we need to do is import pandas as PD, and we then need to read the data into Excel. And if you recall, this takes a copy of the data, so we're not working on the original data file here. You can see that the data has been brought into Python and into VS Code here, and we've got the head of the data displayed on the screen. And you can also quite clearly see here the hidden characters that we alluded to earlier in the tutorial. It is this /n that tells Excel, and in fact tells anything that reads text files, to add a line break in between the items in that text string. So this is the data we're going to have to clean. Step 1 in this cleaning process is to implement the cleansing activities from the last exercise, whereby we took out the pound -- common and forced this number to be a float variable. I've implemented this here in step 1 in a what would be described as a more Pythonic way. So the code from the last exercise has been implemented here in a single line of code. Now, this carries out exactly the same activities as it did previously. It carries out the replace activity. What is a little bit different here is I've used a regular expression. So this parameter here is set to regular expression equals true. And we'll cover regular expressions in a future article. But what it basically says here is find pound dash dash dash, or, the vertical line means or, a comma, and replace it with a null space. We've then asked it to take those new values and force them to be a float. And that has then all been assigned back onto the price per unit column. So that is a more Pythonic way and a simpler way of implementing the cleansing activity from the last exercise. The next activity is to calculate the total order value. Now this is a very simple calculation. This is the volume of units ordered times the unit price. Something that could be implemented very easily in Excel with a formula, and the good news is it is also something that can be implemented in Python very easily. When you have data in a data frame in Python, each of the individual variables is what's known as a pandas data series. And if those panda series have the same dimension, so the same number of items in them, then you can actually apply mathematical operations directly to them, and it carries it out on a pointwise basis. So the corresponding values will have those mathematical operations applied to them. This is a process called broadcasting. And we cover this in the written article supporting this tutorial video, and we also link out some additional information on broadcasting should you need to know it. But the good news is, in this case, it means we can apply the formula we need to very simply. So we can very simply say, create a new column called total order value, and we want that value to be the number of units ordered times the price per unit. And that then calculates the value. So I've limited the display on the screen here to just the head of the three attributes or the three variables that we're working on here. And you can quite clearly see that it has multiplied 100 by 289 to get 28,900 in the total order value. So that's what we mean when we say pointwise multiplication. It takes the corresponding values in each of the pandas data series and performs the mathematical operation, which in this case is multiplication, to give us the new value. Next step involves splitting columns into multiple columns based on the delimiter. Now, if you're familiar with a function or a feature in Excel called text columns, we're going to be doing the same thing, but in Python. The text columns feature in Excel allows us to identify a delimiter. So let's take this list of email addresses, for example, and take the @ symbol as the delimiter. And it allows us to say that we want to split this column into two columns based on the @ symbol being the delimiter. So if we apply this, we see that immediately the address has been split in two, the @ symbol has been dropped, and we have two columns of data. So we've split the data into two. We're going to do the same thing in Python now, and the split function is an incredibly useful function in pandas, and we're going to see how to apply it. So the str.split function is what we're going to use. Now, before I actually run the code to clean the data here, I just want to take a bit of time to explore the split function in a bit more detail. So first of all, remember that we are working with the client address data, and we want to split this data into the individual columns. And we've already identified that we've got this symbol here, the /n line break identifier, that we can use to break this down into its individual columns. So we're just looking at the data within the client address data series here. I'm now going to apply the string split function and say split this into individual elements based on every instance of /n you find. Now for the first running of this, I'm just going to take out expand equals true as well. So we can see here that we've applied the string split function to the data series, and it's returned a list of individual items through based on the positioning of the /n. That list is currently within a single data series, and when we split the data, we want to split this into individual columns. If we recall the second principle of tidy data, variables are their own columns in the data set. And this is where the expand element comes in, or the expand parameter comes in. By default, expand is set to false, so we don't have to add it and it doesn't expand the data. But by setting this to true, it now gives us a data frame where each individual element has been split out into its own column. By default, it's called these columns 0, 1, 2, 3, and 4, and we'll see in a second how to rename those. So if we just fast forward a bit to the code that cleans the data, you can see here in the second line of code we've got the same split function that we explored a few moments ago, and we've assigned that back onto the messy data frame, but we've called this set of columns here address details. Now the first line in this box defines the address details list, and you can see here it's called street, mailbox, country, county, mail code. That will give each of those individual columns that we saw a second ago the respective names. So that will add these columns into the messy data frame and then write on the various columns that have been split out from the client address. Because we no longer need the client address, we can drop it from the data frame, and we can do that by saying drop client address from the first access, which is the columns in a data frame or a 2D data frame. And we're then going to explore the output of that data. So let's just quickly run that, and you can see here that we have added street, mailbox, county, country, and mail code into our messy data frame, and we have dropped the client address. Step 4 is very similar to step 3. This step involves us extracting an individual's name from the first part of an email address. So we're going to apply the same split function to get at the first part of that email address, their name. But we're going to have to come at it slightly differently, as we need to discard the information we're not interested in, the company part of the email address. Let's have a look at how we do this in code. The first line of code you can see here will apply a split function based on an @ symbol. We're going to expand the data, and if you recall from the last step, that will give us a data frame split into 2 columns based on the @ symbol being the delimiter. Column 0 has the name in that we're interested in, and column 1 has the company name. Now for this example, we only need the data that's contained within column 0. So we're going to index this data frame using the square brackets and 0 to just limit the data to this first column. So let's just run this bit of code here to look at that, and we can see that with the addition of the square brackets and 0 indexing this data frame, it just returns the first column of names. So that gives us access to the column of data we're interested in. Now we've still got a little bit of cleaning to do here before we can get it into the format we need. We've got a dot in between the first name and surname here. We're going to replace that with a space. We've seen the code to do that several times. It's the str.replace function, so we're going to implement that off the back of splitting the data out around the @ symbol and limiting it to the first column. We're going to do this in a slightly more Pythonic way here, because we're going to do it with one line of code. So we have the first bit of code here that splits the data out based on the @ symbol and limits it to the first column. We then to that apply the replace function to replace the full stop with a space, and we then assign that back onto a new variable in the data frame called order name. And if we run that line of code, we can see here we have the messy data frame as we'd expect, and we have order name added in with the name space surname as expected. Step 5 involves a little bit of tidying on some of the columns that we've created so far in the cleansing process. If we have a look at the order name and the country, 2 attributes we've extracted in the early steps, then you can see that the data within them, the values within them, are all in capitals. Now, something we can do in Excel is change the capitalization of a value in the cell, and it's also something we can do very easily in Python as well. So the code to do that is similar to some of the code we've seen before. It's the str.title function, or upper, lower. There's variants of this function that will give us different outputs. And actually, let's just have a look at what some of these do before we actually implement them in the cleaning code. So if we apply the str.title function to the country series, and actually, let's just return the head of this data as well. We can see that this has capitalized the first letter of the word. It's given us a title case for the values that are in the data series. Similarly, we could use a lower function, and it would convert it all to lowercase. Or we could use upper. Now, this isn't really going to do anything because it's already in uppercase. We can easily convert the text to be in whatever case we like, and there's a range of functions that are worth exploring in the pandas documentation to manipulate the capitalization of text. But in terms of implementing this on the data, it's a very, very simple task to do. We call the str.title function on the country data series and assign it back onto the country variable within the data frame, and likewise with the order name, and that will correct the capitalization on those values. So if we run that code and very quickly have a look at the output, you can see that the country has been correctly capitalized, and if we just scroll over to the right, you can see that the order name for the individual has been correctly capitalized as well. Having successfully completed step 5, we can now go on to step 7. Bear with me for a second here, because there is a method in my madness regarding missing step 6. I want to show you the impact that not implementing step 6 has on step 7 before we go back and implement step 6. Step 7 is where we are looking at merging the two data sets we have together to produce a single data frame for analysis. And the pandas function that does this for us is a merge function. Now, a merge function works in exactly the same way as a database merge function does if you are familiar with SQL. Based on a type of join, it will go off and merge the data in a specific way. By default, pandas implements an inner join on the data. And what that means is that under certain circumstances, the merge function will behave in a very similar way to a VLOOKUP function. Now, I'm not going to cover types of joins here and how the merge function implements them, but I would encourage you all to go off and research this in your own time. To see the impact of a merge function, I want to go back to viewing the data in Microsoft Excel. So we have two tables. We have our messy customer data, which is the table you can see here on the left-hand side of the screen. And we have the data that we want to look up into the left-hand table on the right-hand side of the screen, the company data. Now, the first thing to note about these two data sets is they have a common attribute. They have a customer attribute in both. So column B and column A. Now, this is important because it gives us a field to link these two tables together. There is a field we can link on. And when we perform a merge, what we're asking the data frame to do, or what we're asking the merge function to do to the data frame, is to go off and find every value in column B, go off and find the corresponding values in the right table based on whatever value it's got here. So customer 1 goes to customer 1, look up these values, so the customer name and the sales representative. Now, that works perfectly if you only have one instance of every customer in your right table. The smarter and sharper-eyed amongst you may have already noticed that we've actually got some duplicates in this right table here. Now, what that actually does is when it comes to look up customer 4, it doesn't know how to manage those duplicates, so it actually starts permuting every single possible combination it can find. So for example, for order 40, if we merge this data as it's currently shown on the screen, it will produce one line of data in the new data frame, having looked up the data from row 5, sorry, and it would then look up one line of data, having looked up the data in row 6. It will duplicate the responses because we have duplicate values in the right table. So let's have a look at the impact of this in Python. So first of all, I'm just going to look at the shape of the messy data frame before we implement any merge on it. So we've got 50 by 12, 50 rows by 12 columns, or 12 attributes. The merge function takes the left data frame, or the messy data frame, merges it with the company data, the right data frame, on the customer field. Now if we look at the shape this then returns, we can see it's 61 by 14, so it's added in the 2 additional columns that we're expecting, but it's also duplicated a number of rows, and we're now not getting the desired behavior in the output because of the duplicates in the right table. So how do we resolve this? Well, we need to remove the duplicates, and this is where we go back to step 6. The first line of code in step 6 brings in the company data from Excel and just gives us the output of the shape. So it is 5 rows by 3 columns, which is what we saw on the screen in the right table in Excel a few moments ago. The pandas function drop duplicates does exactly what it says on the tin. It drops duplicates from the data frame. It's a very versatile function, and based on the parameters you pass it, you can limit the checks for duplicates to specific attributes within it, or you can check for everything as it does by default. Without passing any attributes, it will also keep the first instance of a duplicate it finds and drops the rest. So by applying this function to the company data, it notices that rows 3 and 4 in this data frame are identical, and by default it will keep row 3. So if we run drop duplicates on company data and assign it back to company data, and then look at the shape and output it to the screen, we can see it's done exactly this. It's dropped the duplicate, it's kept row 3, and the company data frame now has no duplicates in it. So what this means is when we now go back to step 7 and run exactly the same code that we ran a moment ago, we can see that the merge has no longer duplicated the number of rows in the data frame, but it has added in the 2 columns that we're interested in. So we can now carry out the cleaning tasks, and if we look at the shape of the data before the merge, after the merge, and perform the merge on the data and now assign it to a new variable called clean data, because this is the last cleaning task we're carrying out, we can see that we have successfully looked at 2 columns without adding in any duplicates to the data. Now for this example, we're dealing with a relatively small data frame, but if you are dealing with data frames with hundreds, thousands, tens of thousands, and even more rows of data, the ability to spot duplicates isn't something you can quickly eyeball in a data frame. So it's always worth taking a little bit of care when you are performing merges in Python, because even an unexpected duplicate can have very unexpected effects on the data, and unless you check it, you may not pick it up and catch it. So when performing a merge, it is always worth double checking and being careful about your data frame sizes before and after the merge, and ensuring that nothing unexpected has happened. Having completed all of our cleansing activity, we can now export the data back to Excel. This is done in the same way as before, using the toExcel function. But the slightly different approach this time is that I have applied a new ordering to the columns. So in the list I've highlighted on the screen, I have defined the order of columns that I want in Excel. And then when we call the toExcel function, we call it on an instance of the clean data column, which then asks it to apply the column order to that data frame. So this ensures that when the columns are in Excel, they are in the order that we outline in this list. As before, I've set the index value to false so that it doesn't output the indices of the rows into Excel, and that will output the data for us. In fact, you can see here that having run that cell, it has created the clean order data in the folder that we are working in. So I'm just very quickly going to open that file up, bring that on from another screen, and you can see here that we've got all the data in our data frame in the order specified, and we can now very quickly carry out some of the analysis that has been requested of us with a few very simple operations in a pivot table. So for example, three fields dropped into a pivot table, and you can see we've got the total orders and we've got the total order value for each customer. This brings us to the end of our video on how to clean data in Excel with Python. In this video, we've demonstrated how 5 very common Excel data cleaning techniques can be implemented with a few lines of Python code. In future videos, we'll go on to look at how we can move past the capability of Excel using Python, because using Python and learning about Python opens up a whole new tool chest of tools for us to use as data analysts, data scientists, and machine learning engineers.